What are stars? Stars are massive balls of glowing plasma powered by nuclear fusion at their cores. They are born from giant clouds of gas and dust called nebulae. Under gravity, these clouds collapse, heat up, and ignite fusion, marking the birth of a star. Fusion: hydrogen atoms fuse into helium, releasing enormous energy as light and heat. This process keeps stars stable, balancing the inward pull of gravity with the outward push of radiation. Our Sun is an ordinary star, but stars can range from tiny red dwarfs to massive blue giants, too. The life cycle of stars: stars live for millions to billions of years, depending on their mass. Birth: stars are born in stellar nurseries, nebulae, such as the Orion Nebula. Main sequence: stars spend most of their lives here, steadily burning hydrogen into helium. The Sun is currently in this phase. Red giants and supergiants: when hydrogen runs out, stars expand and cool, turning red. Massive stars become enormous supergiants. Death of stars: low-mass stars like the Sun shed outer layers to form a planetary nebula, leaving behind a white dwarf. Massive stars end in supernova explosions, producing either neutron stars or black holes. Stars not only shine but also create elements like carbon, oxygen, and iron in their cores, spreading them into space when they die. Without stars, planets and life could not exist. 3. Types of stars: red dwarfs, smallest, coolest, longest-lived stars. Yellow stars, like the Sun, medium size and lifespan. Blue giants: huge, very hot but short-lived. White dwarfs: the remnants of dead stars. Neutron stars: ultra-dense, city-sized remnants of supernovae. Black holes: gravity so strong that not even light can escape. Star clusters: stars are often born together, forming groups. Open clusters: loose groups of young stars, for example, the Pleiades. Globular clusters: spherical groups of old stars, tightly packed. Studying clusters helps astronomers understand stellar evolution. What are galaxies? Galaxies are massive systems of stars, planets, gas, dust, and dark matter, all bound together by gravity. They can contain billions to trillions of stars. Our galaxy, the Milky Way, is home to at least 100 to 400 billion stars. Types of galaxies: spiral galaxies, like the Milky Way, with arms spiraling around a central bulge. Elliptical galaxies, shaped like spheres or ovals, often older and redder. Irregular galaxies, chaotic shapes, often formed from galactic collisions. The Milky Way galaxy, about 100,000 light-years across, contains our Sun, solar system, and Earth. Has a supermassive black hole Sagittarius A* at its center. The Sun orbits the center once every 225 million years. From Earth, the Milky Way appears as a glowing band across the night sky, millions of distant stars shining together. Introduction: the night sky. Since the dawn of time, humans have looked up at the night sky in wonder. Long before telescopes, before science, our ancestors saw stars as guides, gods, and storytellers. Farmers used constellations to know when to plant crops. Sailors navigated oceans by starlight. Civilizations wrote myths about Orion the Hunter, Ursa Major the Great Bear, and the Pleiades sisters. But today, we know that stars are not eternal fires painted on a cosmic ceiling. They are giant nuclear furnaces blazing billions of kilometers away, shaping the very fabric of the universe. And galaxies: they are vast cities of stars, hundreds of billions grouped together, each galaxy like a cosmic island floating in the ocean of space. To understand stars and galaxies is to understand the story of creation itself. For without stars, there would be no planets, no life, and no us. The birth of stars: stars are born inside nebulae, immense clouds of gas and dust drifting in interstellar space. Some of these nebulae stretch across hundreds of light years, glowing faintly as starlight excites their gases. Famous stellar nurseries include the Orion Nebula, a vast star-forming region visible with binoculars. The Eagle Nebula, home to the famous pillars of creation, towering columns of gas where stars are being born. Gravity at work: a nebula starts off as a cold, quiet cloud, but gravity slowly pulls its gas together. As the cloud collapses, pockets of denser material form clumps. These clumps continue collapsing until they heat up, glowing from friction and compression. At the heart of a collapsing cloud forms a protostar, a baby star, ignition of fusion. As the protostar grows denser, its core reaches 10 million degrees Celsius. At this temperature, hydrogen atoms begin to fuse into helium. This process, called nuclear fusion, releases vast amounts of energy. When fusion begins, the protostar stabilizes. It has officially become a star. The life of a star: once fusion begins, a star enters the main sequence phase, the longest and most stable part of its life. Small stars burn hydrogen slowly, shining dimly but for trillions of years. Medium stars like the Sun burn steadily for about 10 billion years. Massive stars burn furiously, living only a few million years before dying violently. During this time, a star balances to forces, gravity pulling inward, radiation from fusion pushing outward. This perfect balance is why stars can shine steadily for billions of years. The chemical factories of the universe, stars are not just shining lights. They are cosmic forges that create the elements of life. In their cores, stars fuse hydrogen into helium. Later, helium fuses into carbon and oxygen. In massive stars, fusion continues to heavier elements like silicon and iron. When these stars die in supernova explosions, they scatter these elements across space. The iron in our blood, the calcium in our bones, the oxygen we breathe all were forged in the hearts of stars. As Carl Sagan famously said, we are made of star stuff. The death of stars, just like living beings, stars are born, live, and eventually die. Their deaths are as fascinating as their lives, and often far more dramatic. The way a star dies depends entirely on its mass. Death of Sun-like stars, low to medium mass. Our Sun and stars of similar size live for billions of years, but eventually they run out of hydrogen fuel in their cores. 1. Red giant phase. Once hydrogen is gone, fusion slows. Gravity causes the core to contract while the outer layers expand enormously. The Sun will grow so large it will swallow Mercury, Venus, and possibly Earth. The surface cools, giving the star a reddish color. 2. Planetary nebula. The star sheds its outer layers into space, creating beautiful glowing shells of gas. Famous planetary nebulae include the Ring Nebula and the Helix Nebula. 3. White dwarf. At the center remains a small, dense core about the size of Earth but with the mass of the Sun. It no longer fuses fuel but glows faintly with leftover heat. Over trillions of years, it will cool into a cold, dark black dwarf. Death of massive stars. Massive stars, at least 8 times the mass of the Sun, live fast and die young. 1. Supergiant phase. After hydrogen runs out, they fuse heavier elements helium, carbon, oxygen, and more layer by layer. Their cores resemble an onion, with different elements fusing at different layers. 2. Supernova explosion. When iron builds up in the core, fusion stops. Gravity suddenly crushes the core, triggering a massive explosion. In a fraction of a second, the star blasts apart with a brightness that can outshine an entire galaxy. Supernovae are among the most powerful events in the universe, creating gold, uranium, and other heavy elements. 3. Neutron stars. If the core left behind is between 1.4 and 3 times the mass of the Sun, it collapses into a neutron star. A neutron star is only about 20 kilometers wide, yet so dense that a teaspoon of its material weighs billions of tons. Some neutron stars rotate rapidly, emitting beams of radiation. We call them pulsars. For black holes, if the core is more massive than 3 suns, gravity wins completely, crushing matter into a point of infinite density. This forms a black hole, from which not even light can escape. Exotic stars. While most stars end as white dwarfs, neutron stars, or black holes, there are fascinating variations. Magnetars, a type of neutron star with magnetic fields trillions of times stronger than Earth's. They can release powerful bursts of gamma rays. Quark stars, hypothetical objects denser than neutron stars where particles break down into pure quarks. Binary stars, many stars exist in pairs or groups. In binary systems, mass can flow from one star to another, sometimes creating dramatic supernovae. Star clusters, families of stars. Stars are not usually born alone. They form in groups within nebulae and often remain bound together by gravity. Open clusters, loose groups of a few hundred to a few thousand young stars, often found in the spiral arms of galaxies. Example, the Pleiades' seven sisters, visible in the winter sky. They shine brightly with blue stars and are relatively young, tens of millions of years old. Globular clusters, spherical groups of up to 1 million old stars tightly packed together, found in the halos of galaxies. Example, M13 in Hercules, a glittering bowl of ancient stars. Some globular clusters are over 12 billion years old, nearly as old as the universe itself. Studying star clusters helps astronomers understand stellar lifespans, since all stars in a cluster form at the same time but live different lengths depending on mass. Why star death matters? Star deaths are not just cosmic fireworks. They play a vital role in the evolution of the universe. Supernovae scatter heavy elements like carbon, oxygen, gold, and uranium into space. These elements enrich future generations of stars and planets. Without star death, there would be no rocky planets, no water, and no life. In a way, we are literally the children of dead stars. Galaxies, the cities of the universe. While stars are the individual lights of the cosmos, galaxies are their homes. A galaxy is a vast collection of stars, planets, gas, dust, and dark matter, all bound together by gravity. Galaxies can contain billions to trillions of stars. They come in many shapes and sizes, from elegant spirals to chaotic irregulars. Astronomers estimate there are about 2 trillion galaxies in the observable universe. When you look at the Milky Way band across the night sky, you are seeing only a tiny fraction of our own galaxy. Each faint glow is the light of countless distant suns. Types of galaxies: spiral galaxies, shaped like flat disks with spiral arms winding around a central bulge. They contain both young and old stars, as well as rich clouds of gas and dust for star formation. Example, the Milky Way galaxy and the Andromeda galaxy. Elliptical galaxies, shaped like spheres or elongated ovals, contain mostly old, red stars with little gas or dust, meaning few new stars are born. Some are giants with trillions of stars, others are dwarfs with just a few million. Irregular galaxies, chaotic in shape, often formed by galactic collisions, rich in gas and dust, bursting with new stars. Example, the Large and Small Magellanic Clouds, visible in the southern hemisphere. The Milky Way, our galactic home. The Milky Way is the galaxy we live in. It is a vast spiral system, about 100,000 light-years across. Contains 100 to 400 billion stars. Our Sun orbits the galaxy's center at a speed of 828,000 kilometers per hour, completing one revolution every 125 million years. The structure of the Milky Way: galactic bulge, a dense central region full of older stars. Spiral arms, home to younger, brighter stars and nebulae where new stars are born. Halo, a spherical region surrounding the galaxy, containing globular clusters. The central black hole. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole about 4 million times the mass of the Sun. Though invisible, its presence is revealed by the rapid orbit of nearby stars. Other galaxies in our neighborhood. We are not alone. The Milky Way belongs to a galactic family called the Local Group. The Andromeda galaxy M31 is our nearest spiral neighbor, 2.5 million light-years away. The Milky Way and Andromeda are on a collision course and will merge in about 4 billion years, forming a new galaxy sometimes called Milkdromeda. Other members of the Local Group include the Triangulum galaxy M33 and dozens of small dwarf galaxies. Beyond the Local Group lies the Virgo supercluster, a vast collection of thousands of galaxies. Galaxy clusters and superclusters. Galaxies rarely exist in isolation. They form clusters containing dozens to thousands of galaxies. Example: the Virgo cluster has over 1,300 galaxies. Clusters themselves group into even larger superclusters, like the Laniakea supercluster, which contains our Milky Way. These structures form a cosmic web, with galaxies linked like beads on giant filaments stretching across the universe. Dark matter, the invisible glue. When astronomers measured galaxies, they discovered a puzzle. Stars at the edges of galaxies orbit faster than expected. Based on visible matter, galaxies should have flown apart. The solution: dark matter, a mysterious, invisible substance that does not emit or absorb light. Makes up about 27% of the universe, while normal matter is only 5%. Acts as the glue holding galaxies and clusters together. We cannot see dark matter directly, but its gravitational effects are undeniable. Without it, galaxies would not exist as we know them. Dark energy, the great expansion. As if dark matter weren't mysterious enough, astronomers also discovered dark energy. Observations show that the universe is not only expanding, but accelerating in its expansion. Dark energy, a force we do not yet understand, is pushing galaxies apart faster and faster. It makes up about 68% of the universe. This means that 95% of the cosmos is invisible. We only understand a tiny fraction of reality. The fate of galaxies. What will happen to galaxies in the far future? Several possibilities exist. 1. Big freeze. If dark energy continues, galaxies will drift farther apart until stars burn out, leaving a cold, dark universe. 2. Big rip. If dark energy grows stronger, it may eventually tear galaxies, stars, and even atoms apart. 3. Big crunch. If gravity someday overcomes expansion, galaxies may collapse back together, possibly sparking a new Big Bang. Whatever the outcome, galaxies are not eternal. They too are part of the ever-changing cosmic story. Humanity's connection to the stars. Long before astronomy became science, stars shaped the destiny of civilizations. Navigation. Ancient sailors used the North Star Polaris to cross oceans. The Polynesians navigated the Pacific by memorizing star patterns. Calendars. Egyptians built temples aligned with Sirius, whose rising signaled the flooding of the Nile. The Mayans tracked Venus to guide rituals and agriculture. Mythology. Every culture wove myths into the stars: Orion the hunter, Scorpio the scorpion, and countless others. To early humans, the stars were both maps and sacred stories. Even today, we still find meaning in constellations, linking the night sky to our history, imagination, and identity. We are stardust. Science deepens this bond. We now know that the carbon in our cells, the oxygen we breathe, the calcium in our bones, were all created in the hearts of stars long ago. When those stars died, they scattered their elements into space. Eventually, those atoms came together to form Earth and us. As Carl Sagan famously said, we are a way for the universe to know itself. This poetic truth reminds us that we are not separate from the stars. We are the stars, evolved to wonder about themselves. Future exploration of the stars. The next chapters of astronomy promise even more discoveries. Exoplanet surveys. Missions like TESS and Plato are searching for Earth-like worlds orbiting distant stars. Gravitational wave observatories. LIGO and Virgo have already detected the ripples of colliding black holes and neutron stars. Future detectors will reveal even more cosmic events. Interstellar missions. Projects like Breakthrough Starshot dream of sending tiny spacecraft to Alpha Centauri, our nearest star system, within this century. Colonization and travel. Though still science fiction, humanity dreams of harnessing fusion energy or wormholes to explore the stars firsthand. The philosophy of stars and galaxies. Beyond science, the stars hold a deep philosophical meaning. They remind us of humility. Our sun is one of hundreds of billions in the Milky Way, itself just one of trillions of galaxies. They inspire hope. If life formed here, perhaps it has formed elsewhere, under alien skies. They give us perspective. Wars, borders, and divisions on Earth are invisible from space. From the stars' view, humanity is one. As astronaut Edgar Mitchell said after returning from space, you develop an instant global consciousness, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. Conclusion: our endless journey. The story of stars and galaxies is the story of the universe itself. Stars are born in nebulae, live brilliant lives, and die in spectacular explosions. Galaxies are the grand stage upon which this drama unfolds, billions of suns lighting up cosmic cities. Dark matter and dark energy remind us that much remains hidden, waiting to be understood. Humanity, though small, carries the gift of curiosity, the ability to ask, to learn, and to dream. When you gaze at the night sky, remember, those tiny points of light are not just distant suns. They are stories billions of years old, shining across time and space to reach your eyes. And perhaps, somewhere out there, another being is looking back, wondering the same thing. The universe is vast, mysterious, and humbling. But it is also ours to explore. The journey has only begun. As we come to the end of this incredible journey through the cosmos, let's take a moment to reflect. From the fiery birth of stars in nebulae, to the dazzling spiral arms of galaxies, to the mysteries of dark matter and the promise of future exploration, we've only just scratched the surface of the universe's grand story. Every star you see in the night sky is a sun, many with planets of their own. Every galaxy we observe is a cosmic city filled with billions of stars. And beyond what we can see lies a universe far larger and more mysterious than we can imagine. But perhaps the most profound truth of all is this: we are not separate from the universe, we are part of it. The atoms in our bodies were forged in the hearts of ancient stars. When you look up at the night sky, you are quite literally looking at your origins. So next time you step outside on a clear night, pause for a moment. Look at the stars. Think about the galaxies beyond. And remember, you are made of stardust, living on a small planet that orbits an ordinary star in an extraordinary universe. If you enjoyed this journey, don't forget to like this video, subscribe to the channel, and hit the bell icon, so you never miss more cosmic explorations. Share this with friends who love science, and let's keep spreading the wonder of the universe together. Until next time, keep looking up, because the stars are telling a story, and it's the story of us all.